In this video, I will show you how to apply transpose operation on a two-dimensional matrix. So for that, first I will open the editor, and before typing the program, first I will show you what is transpose operation, that how it can apply it on a two-dimensional matrix. So if you see here, the original inputs are like this. This is row 1, this is row 2, and this is row 3. So if you observe, the first row becomes here as first column, like this one. After applying the transpose operation, the first row becomes first column in the output matrix. The second row becomes the second column in the output matrix. The third row becomes the third column in the output matrix. So rows becomes columns, columns becomes rows. That procedure is called as transpose operation, which we can apply it on a two-dimensional matrix. Now we'll start coding this one by applying this logic. So file, new, source file. First include the relevant header files. Then beginning main function. Then declare the arrays. So for my arrays, I need to define the size. So at the beginning, using pre-processor directive define, I will declare the size of the array. So for I am interested to transpose operation, I want to apply it on a 3 by 3 matrix. So I will take it as a size value as 3. Now I want to declare a two-dimensional array with the size. Row size is 3, column size is 3. That means it becomes a 3 by 3 matrix. After applying this operation, the output is stored in resultant matrix. Suppose if I have assigned, if I declare that array as B, for that also, after transpose also, we will get the same size. Why? Because it is a 3 by 3. So 3 rows becomes 3 columns becomes 3 rows. Now, and we need to one loop control variable, that is I. So in future, if you require any variables, again we will come back here and we will declare it here. So as of now, we need one input array, that is A, and after applying the transpose operation, we are going to store the output array, that is B. And to iterate the loop, because we need to read the elements of the array, for that I am using one more loop control variable I. So we will provide a message to the end user, enter number of elements matrix A. So using the for loop, starts from index value 0 up to the last index value -1. Last index value is located size -1. Each time the loop is incremented by 1, that is I plus plus, I plus plus. And after that, here using scanf function, we will try to read an array. First array, that is I. As it is a two-dimensional array, we need one more nested for loop. That means after the outer for loop, we need to declare one more for loop. So outer for loop represents the row number, inner for loop represents the column number. So we need one more loop control variable, that is called J. For outer for loop is controlled by variable I, and inner for loop is controlled by another variable, loop control variable J. So this is also, we will run up to the size -1. Size -1 is nothing but up to the means we need to provide equal symbol. J. Size -1 means last index element. Last element index value is called size -1, and each time J value is incremented by 1. Then we will try to scan. Then we will try to scan the input value of input array, that is A of ij, like this. So this statement should end with semicolon. Now we need to close the outer for loop. Outer for loop is closed. Then So after reading input values, for our purpose, we need to display the array again. So how do we display the array? A two-dimensional array, we need a nested for loop. In place of scanf statement, we need to provide printf statement. If you provide printf statement, if you remove this ampersand sign, then it prints the values of the two-dimensional input array, that is A. And before displaying the array, we will provide a message, elements of matrix A, elements of matrix A. In the next line, the elements will be printed. Now, this we are printing the array elements before applying the transpose operation. Now we are going to apply the transpose operation on the input array. So elements of transpose matrix. Transpose matrix. What we named it as? We named it as B. Matrix B. So again we need nested for loop. Whenever we need to iterate, whenever we need to read or iterate or print, we always need two dimension. For two dimensional array, we always need nested for loop. But if you observe here, we need to print the, see, rows becomes columns, columns becomes row. Actually this outer for loop control variable is row indexing. Inner for loop control variable j is called column indexing. Now our target is rows becomes columns, columns becomes rows. That means I becomes j, j becomes I becomes j, and j becomes I. If I change the variable names here, in place of j I keep it I substituted I, in place of I substituted j. So j and I. Then I need to test. I need to test the result. And one more thing, each time a particular row, after printing the particular row elements, after closing the inner for loop, immediately we need to apply new line, so that each row will be printed in a new line. So the same thing we need to apply while printing after transpose also. This printf slash n is while printing before applying the transpose operation. So after closing the inner for loop, we need to apply new line. So save this program with some valid name. So transpose demo.c. So check for syntax errors by compile the code. So I try to compile the program. So it is showing yes, there is a missing. Actually for loop is closed, but above we begin the main function. We need to close the main function also. So that braces is missing. So once we made any changes, save it and compile the program. So there are no errors and no warnings. Now we will check the output by clicking the run button. So now it is asking to enter the number of elements of matrix A. How many elements are there? As the row size is 3, column size is 3, because we declared the array size as A of size, and size. Size values we declared as by using the preprocessor directive, define size as 3. That means A33 means 3 by 3 means how many elements we need to enter? 9 elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. Then what we are trying to do, so using scanf function, all these elements will be assigned to corresponding indexing values. Then once we try to print, see, elements of matrix A, 1 2 3 4 5 6 7 8 9. Now this 1 2 3 is becomes column, this 4 5 6 becomes second column, this 7 8 9 row becomes third column. Or if you see like this, 1 4 7, here it is column, that becomes row. 256, 258, it is a column, that becomes second row. 369, here it is a third column, that becomes third row. So now we need to maintain some space between the elements. So how do we maintain the space between the elements? By applying, in place of 4D, if you place 4D, it will maintain some space between one digit to the next digit in the same row. So once we made any changes, save it and compile, run the program. Now 1 2 3 4 5 6 7 8 and 9. So total 9 elements are expected by using that nested for loop, as the size is 3 by 3. Now you can check how it looks. So once I given percentile 4D, automatically it maintains some space between the one digit to the next digit. So previously that space was not generated because I forget to give that 4, digit 4 after percentile. So how it helps to maintain the space between the digits, this one, Previously we given only percentile d. Now I given percentile 4d at two times. After transpose and before transpose also I given. So like this, by changing the index variable loop control variable names, we automatically obtain the transpose of the given matrix. Rows becomes columns, columns becomes rows.